All right, what's up, math minions? We're going to continue talking about vectors, and this time what we're going to do is we're going to start talking about something that's very important, and that is the direction of the vector, the angle of the vector. So today's learning target, I can determine the horizontal and vertical components of a vector when given the magnitude or the length and the direction or the angle of the vector. Just kind of a little bit of pre-teach right now. What we are going to start seeing is we are going to start seeing vectors given to us where we know the magnitude and we know the angle of that vector. Okay, so we're going to break it up and we're trying to find those horizontal and vertical components. Okay, so what this is really going to turn into is some of our right triangle trigonometry. Okay, so that's what I want you guys to think about as I change screens here. Now, again, you should already have your notes out. You should be ready to take notes. Pause the video when you need to copy stuff down. Have a calculator ready to do some of the same calculations we're doing, but all the stuff I do right now, you should be doing as you work through the video with me. All right, so let's go in here. Let's take a look at some things. All right, so like I said, we're going to be finding components of a vector when we are given the magnitude and the direction. Okay, so there's that picture I just drew. We're going to know the length of the vector. We're going to know the angle the vector is taking off at, which direction it's going. So here's what you need to know. It all goes back to SOHCAHTOA. If we have a vector where we want the components, or we want to write it as a linear combination, the horizontal component is going to be the magnitude times cosine of the angle, and the vertical component is going to be magnitude times sine of the angle. Again, this is for the horizontal component, and this is for the vertical component. And that should be familiar because when we looked at our right triangles and we started to do some things, especially early in the first 6 weeks, when we were building our unit circle, we had these triangles we were dealing with. If I know the angle that's being made, then the horizontal side is the adjacent side, and the vertical side is the opposite side. The magnitude is the hypotenuse. So that takes us back to our SOHCAHTOA. Remember, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So it turns out, again, when we want that vertical part, that's the opposite, we're going to use sine. If we want the horizontal part, that's the adjacent, we're going to use cosine. Okay? So again, this is the main idea. All right? That if we want the components, we just do magnitude times cosine of the angle to find the horizontal. We do magnitude times sine to find the vertical. Again, I want you to notice it's even alphabetic, just like we have said since we started talking about trig, right? A, B, cosine, sine, horizontal, vertical. Okay, this down here is just kind of a shortcut of how to get to that answer. If we want it in component form, the linear combination form is magnitude times cosine of the angle. That gives us the horizontal I part, and then magnitude times sine of the angle gives us the vertical J part. Okay, all right, so let's take a look at an example here. Again, pause the video as you need to if you want to copy this into your notes. It's a good idea. If vector v has a length of 8, or we could say magnitude of 8, we could say vector v's magnitude equals 8, and it has a direction of 60 degrees, or we could say theta equals 60 degrees. Find the horizontal and vertical components and write it in terms of vectors I and j. So in other words, we want to write it as a linear combination. Again, here's what they gave us. Magnitude of the vector is 8, and the angle or theta of the vector is 60 degrees. Okay, all right, so again, let's just kind of visualize that. I know, remember 60 degrees on our unit circle, 60 degrees goes over into quadrant 1, right? 0 to 90 is quadrant 1, so 60 degrees means this vector is taking off at a 60 degree angle, and it's got a length of 8. 60 degrees, if I were to put this at the xy axis at the origin there, then this is kind of what this vector is going to look like. Okay, we want the horizontal and we want the vertical. All right, I've tried to make it easy for you and use things that are alphabetic, X, Y. I don't want to use X, Y because those tend to get confused with coordinates. Okay, but I want the horizontal component and the vertical component of this vector. Again, the horizontal component is the adjacent side to the 60. So if I want A, I'm going to take the magnitude times cosine of the angle. Right? If I want A, I would say cosine of 60 degrees equals the adjacent side A divided by 8. Well, you remember the math that's got to take place. I'm going to multiply by 8 both sides to get A by itself. So if I get A by itself, A is going to be 8, the magnitude, times cosine of 60 degrees. So 8 times cosine of 60 degrees. Now, at this point, we're going to do it one of two ways. Your choice. I think when it comes to how I want you to put stuff in Canvas, we're just going to use our calculator. Now, again, since we got degrees, we better be in degree mode. Okay, if you're going to use Desmos, hit the little wrench and put it into degree mode. And we're going to do 8 cosine of 60 degrees. Okay, that's exactly 4. That's wonderful. I'm going to say A equals 4. Okay, if we want to do the B, the vertical part, if I go back over here and look at the vertical part is the opposite side. And again, the hypotenuse is the magnitude, is the 8. So if I want to do that opposite side, opposite hypotenuse, from our SOHCAHTOA magic word, opposite hypotenuse is sine, so we would say sine of 60 degrees equals opposite over hypotenuse. And again, the same math is going to take place. If I want B by itself, I'm going to multiply by 8, multiply by 8. That's why we can just say, real simply, that the vertical part is the magnitude times sine of the angle. Okay, and again, the magnitude was 8. We do 8 times sine of 60 degrees. Get this show up right. We are going to use our calculator, but I'm also going to show you some things that we could end up using our trig chart with. Give me a second here. So we got 8 times sine of 60 degrees. Okay, so you notice that that's not nice. In Canvas, I think I just said go to the nearest tenth, so 6.9. All right. Now, again, technically, that's not exact. So if we want to be more precise, we would go to our trig chart. We would look at sine of 60 degrees. 60 degrees is there, so sine of 60 degrees is square root of 3 over 2. So we could do 8 times square root 3 over 2. And again, since I call that 8 over 1, this is 8 square root 3 over 2. That reduces to a 4 square root 3. Okay, this would be another thing that we could look for our vertical part. Now, finish this off. Let's go ahead and use these decimal versions of them because that's what I said in the assignment in Canvas, I believe. So again, we want to write it in terms of I and j. Remember, the horizontal part gets the I, so 4i, and the vertical part gets the j. So plus 6.9j, and that's how we would type it in to Canvas. Okay, that's it. That's what it takes to find the horizontal and vertical components. Quick little video today about that. Horizontal, cosine. Vertical, sine. All right, horizontal, the A, cosine. Vertical, sine, but it's magnitude times sine of the angle. Okay, that's it. Prepare on Monday to work on assignment on this. We'll see you.